Good morning. My name is Jesus. I am from Mexico. I live in the state of Sonora in the city of Obregón. I am going to speak about the next subject, improved flux performance in the Brackish water reverse osmosis membrane by modification with zinc oxide nanoparticulate and interface polymerization. I'm going to share the presentation. Okay. Um, Good, let's begin. The last year, I published in an article with the same subject in the journal Membrane. The editor MDPI. Here is the abstract about my research. The water is a very necessary for people to have a good quality of life. Around the 32 million households suffer for water scarcity. Worldwide, 2 million people, almost the 26% of the population, lack access to the safe drinking water. It's a big problem. In Mexico, the North Mexico suffer for a severe water shortage due to low rainfall. Orange indicates extreme drought. Brown indicates exceptional drought. Yellow indicates abnormally dry. The state, the state of Sonora is mostly covered by orange and brown color. The solution to mitigate the problem of water scarcity is the reverse osmosis process. This technology used semi-permeable membrane to generate drinking water from seawater. The reverse osmosis process had two problems. Membrane falling, the falling with bacteria, microorganisms, and the falling is the about polarization, is the incrustation of salt in the membrane surface. This is a problem. In about context, we ask observers the following question. What will be the effect nanoparticles in the prepared polymeric composite membranes in the relation the performance in the solution process in terms of permeate flux, cell reaction, and polarization? The general goal, a modified composite membrane with interface polymerization and nanoparticles with recognized anti-befouling effect to evaluate their performance improvement in terms of permeate flux, cell reaction, and polarization. To meet the general goal, the following reagents and material were used: BW3D membrane, mesoryl trichloride, piperaxine, sodium hydroxy, polyvinyl alcohol, and zinc oxide nanoparticles. A composite membrane is formed by three layers, like this graphic. The reagents and materials mentioned above were used in the synthesis of the dense polyamide membrane. A piece of BW3 membrane, 4 inches per 6 inches was cut out. The aqueous solution B of piperazine and zinc oxide nanoparticles was added with a brush. Then the organic solution A uh, of mesoyl trichloride was added, and the reaction was for 1 minute. Then the reaction was stopped in a nitrogen atmosphere and finally was put in the oven to cool the membrane. The characterization of modified and unmodified membrane works as follows. We measure the contact angles, the main functional groups with F, FIR, membrane, we measure the membrane roughness with AFM by FM, membrane morphology with SIM. For the application on the membrane to determine the performance, permeability, permeate fluid, salt rejection, and concentration, polarization was obtained by cross-flow equipment. With this equipment, we obtained the performance of membranes. This equation were used to calculate the permeate flux, permeate flow, concentration, permeate flow, salt rejection, and polarization. We are going to see the result and discussion. Here I show the surface analysis of modified and unmodified membranes by seeing the membrane with 5 milligrams nanoparticles. There is an agglomerate of approximately 450 nanometers and spherical nanoparticles of 100 nanometers or less. In the membrane with 10 milligrams nanoparticles, there is one agglomerate, and particles larger than 100 nanometers, and is more than 100 nanometers. In the membrane, 15 milligrams nanoparticles, there are 6 agglomerates of nanoparticles, a particles less than 100 nanometers. These results were fundamental to conclude with a higher permeate flux was obtained with the membrane prepared with 10 milligrams of zinc oxide nanoparticles. The contact angle was measured with the ionometer. The additional zinc oxide nanoparticle increased the draw velocity in the membrane. The higher the amount of nanoparticles, the contact angle on the membrane decreased, as reported by Brackish et al. 2016 and Perez et al. 2016. The modified membranes showed by FTIR that they contain the carbonyl group of the carboxylic acid and the carbonyl of the amide group. This is agreement with the Alvarez et al. And Tack et al. 2009 indicate that the polyamide network was formed. The size of agglomerate nanoparticles was detected in 2D by FM, ranging from 1 to 2 micrometers. The roughness of membrane was also determined. The membrane with 10 milligrams of nanoparticles is visualized with a lower roughness here. The is according to Lee et al. 2016. Pressure, pressure in megapascal was plotted versus permeable flux of each membrane and 20 and 30 hertz. The membrane with 10 milligrams nanoparticles was superior 9.5% at 20 hertz and 12.2% at 30 hertz compared to the BW 3D membrane. Ravi in 2015 obtained similar results. This is best explained with the following feature. The concentration of 5 milligrams of nanoparticles for a layer of nanoparticles smaller than 100 nanometers. That obstructs the mass transfer of water. Then in the membrane with 10 milligrams, the perfect condition of agglomerate and nanoparticles are created such a way that there is greater mass transfer. With the 15 milligrams nanoparticle membrane, a layer of nanoparticles smaller than 100 nanometers is formed, and the layer of agglomerate is such a way that they obstruct the mass transfer of water. When seen analyzed and permeable fluid result, this finding was postulated. The best result is the membrane with 10 milligrams nanoparticles, zinc oxide. It is plotted pressure versus cell reaction of the membrane. Cell reaction range from 90-60% to a maximum of 97.55%. Isawin in 2016 obtained very similar result with zinc oxide nanoparticle modified membrane from 96% to 98% cell radiation. In the polarization, concentration polarization, linear behavior, we have an R square of 0.965, and 0.96 at 20 and 30 hertz, respectively, according to Martinez Perez et al. 2023 and Noah Martinez et al. 2024. The membranes with 10 milligrams nanoparticles 30 hertz showing the highest concentration polarization result, but the same membrane had higher cell rejection. Therefore, the higher the cell rejection, the higher the concentration polarization at the membrane surface, according to Ismail and Matsuda, 2021. Like conclusions, modification of Brackish water composite, BW20 membrane, TFC with zinc oxide nanoparticles was achieved using the interface polarization technique to improve the permeable flux and its characterization. The FIR signal showed that a new polyamide layer was formed indicate that the acid carboxylic functional group was formed. The contact angle corroborates that has the concentration zinc oxide nanoparticle increased degree of hydrophilicity and the contact angle decrease. The 2D, FM, and SIM results indicate the nanoparticular were best distributed in the surface of the 10 milligrams zinc oxide nanoparticles membranes. The membranes that performed best in the term of permeable flux was the membrane with 10 milligrams zinc oxide nanoparticles. The membrane with 10 milligrams zinc oxide nanoparticles showed a salt rejection of 97.13% and 97.77% for 20 and 30 Hz respectively. The polarization results in the cross-flow equipment show a linear behavior. As the higher the operating pressure, the higher concentration polarization will be above the recommended values. Therefore, it's available to find a balance between the flow of feed water of the industrial or laboratory level with respect to the key variables of process, taking care that they do not exceed the operation limits recommended by the manufacturers. Here's the reference. Acknowledgements to the 50th Global Conference of Polymer Plastic of Composite. De Secretaría de Ciencia, Humanidad y Tecnología e Innovación, Professional Development Programs Teacher, Instituto Tecnológico de Sonora, my student, Patricia Torres, my co-worker, Dr. Sergio Pérez. Acknowledgement, thanks, gracias a todos por su asistencia.